In C, as you know, you declare an integer by saying int x semicolon, isn't it? So we have simply said that x is a variable of integer data type. We have just said that x is a variable of integer data type. So by not saying everything, we have said lot many things by just saying that x is a integer data type. For example, the integer variable x has got a predefined range as per the compiler. Suppose you are working on Turbo C, then 37,784 is the range. But for other different type of compilers, the ranges are different. So just by saying int x, we have said that the range is so and so. C also defines several operations that can be applied on the data type, isn't it? Several mathematical operations like we can do addition. If there are two variables, then we can do subtraction, we can do multiplication, we can do division, and so on. So we need not have to say everything explicitly, but just by saying in text, we have set the range and we have set a type of not set. We have defined the operations which can be performed on this integer data type. At the same time, there are certain operations which cannot be performed on integer data type, isn't it? So, for example, concatenation of two integers cannot happen, isn't it? So, that is how we have said everything, but without explicitly giving all the details. So, C explicitly defines these operations on integer, and the other example of a data type is a stack. So when you say that abstract data type is stack, what is a stack? A stack is based on the principle of last in, first out. That is the last element which is entered into the stack is the first element which has to be removed from the stack. Some operation. So while maybe you are trying to open some application, suddenly this pop-up will come, right? So it has interrupted your activity and it is trying to say give you some kind of a guideline. So what is interrupt handling? Interrupt handling also is based on the stack operations that it would like to clear some cache, it would like to clear some RAM, it would like to say remove some of the large files, so on and so forth. So the operations which can be performed on the stack, in the sense that I told you that simply by saying that in text, we can perform all the arithmetic operations. So also stacks, some operations which are fixed, which can be performed on the stack, and these stacks are used in the basic design of an operating system which we have just seen. The basic operation are push, that is we can push an element into the stack, and the terminology which you have to use is push itself. Then we can if we want to push element into the stack, then first you have to check that whether the stack is full, because what is stack? Stack is a part of the memory, and that memory has got a limitation. So if you want to push an element into the stack, the first thing which you must check is that whether the memory is full. If the memory is full, you obviously cannot push into the stack. Second part is the pop. Pop is means what? Removing it from the stack. As I told you, it is a leaf operation. Last element entered into the stack is the element which has to be removed or deleted from the stack. So again, we have in generalized kind of a fashion, some kind of a function which carries out the pop operation. The item to be removed followed by the name of the function. So remove and return the topmost element from the stack is what we have to expect from this particular function. Precondition, it is just exactly opposite as insert. Insert checks whether the stack is full, whereas the pop has to check whether the stack is empty. Peak. Now peak, it does not remove any element or add any element, but it just simply specifies that which is the element which is at the top of the stack, right? So return the topmost element without making any modifications. Of course, the stack cannot be empty. Is empty is a Boolean type. It returns a Boolean value. Is empty, either it could be true or it could be false. So also is full is also, it will return true or false. So let me go directly to the linked list. Linked list is a dynamic data structure. Dynamic data structure means what? Uh, for example, a data structure that grows and shrinks during the execution. Means what? Gautami. Uh, this slide you are talking about, Gautami? Are you talking about this slide, Gautami? Gautami, can you hear me? Are you talking about this slide to be shown again? Okay. Anything specific, Gautami, which I want you to repeat? See, push is inserting element into the stack. Before pushing, check whether the stack is full. Pop is removing the element from the stack. Before popping out, you have to first check whether the stack is empty. Peak, it returns the topmost element in the stack. Is empty, it returns, it's a Boolean value. Either it is true or it is false. Is full, either it is true or false. Okay. So dynamic list, dynamic data structure, that is a data structure that can grow and shrink during execution. As you are executing, you need to have that facility that the data structure can increase or decrease. For example, an array is a collection of elements where each element could be identified using an index. You know the definition of an array. Whereas linked list means I am trying to compare. When you declare an array, at the beginning itself, the compiler will definitely ask the size of an array. If the size of an array, if you give it as 10, then during the execution of the code, I cannot reduce the size of an array, nor I can increase the size of an array. So if you compare it with the linked list, if you compare an array with the linked list, a linked list is a sequence of nodes where each node is made up of data element and a reference to the next node in the sequence. So it is a composite structure which has got some data values and a self-referential structure. That is, it has got a pointer pointing to a data type which is of linked list data type. So this linked list allows insertion and removal anywhere. Anywhere in the sense you can insert at the beginning of the linked list, you can insert at the end of the linked list, and you can insert in between the linked list also. So you can uh, insert at the beginning, insert at end, or insert in between. That is how it does not restrict you regarding how many nodes your linked list is going to have. Unlike your array, array is a linear structure which is not dynamic. Means during the execution of the program, you cannot modify the size of the array. Whereas linked list is dynamic in the sense that during the execution of the program, on the request of the user, you can remove a node. Linked list can be used for the stack operation, allow insertion of Stack is a data type, gives you that if at all you want to insert, you can insert at the top, and if at all you want to remove, you can remove only from the top. Voice is breaking again. Hello, 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 uh, hello, 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 hello. Is it same? Is it breaking, students, or is it better? Fine, sir. Clear. Okay, okay, okay. So let me go straight away to the linked list because use and stack anyhow we are going to cover it a little later in detail. Okay. Now a word about the self-referential structure. A structure that contains a pointer to a structure of the same data type. If you see the figure, if you see the figure, assume that this is a structure, assume that this is a structure which has got a facility. The first element is an integer data type. So you can store an integer value, say 15. And the second element of the structure is a pointer which points to a same data type, right? It's a pointer which points to another structure of same data type. Okay, so self-referential structure can be linked together to form useful data structures such as lists, queues, stacks, and trees. So in the diagram, the first is your data member, and the second is a pointer, but not any other pointer, but a pointer which points to a structure which is of the same data type. Means as you are seeing it on the screen, the second figure is a structure which is exactly same as the first one, right? So convert this into a C type code. So struct node, what is struct? It is a keyword. Node is the name of the structure which has got two elements in the structure. First element is int data, right, which can store any integer value, and the second element is struct node pointer next ptr, right? Okay, Asya, any clarification regarding this slide? Asya, any clarification regarding this slide? Something which you have not understood? Yeah, Asya, you asked me for the previous slide. Anything which you have not understood? Okay. Maybe probably you might not have understood. This is a notation. This is a notation which indicates null, right? The pointer, the this particular at this particular location you are saving an address of the next node. But this notation says that the pointer node is having a null value. The pointer is having a null value. Okay. So if you convert that into the code, int data, int data, and struct node a pointer, the name of the pointer is next ptr. Now this, the fact that the name of this structure is struct node and struct node and we are putting pointer. Therefore, it is called as self-referential structure. Means what? One of the element of this structure is a pointer which is pointing to a same data type, right? It's pointing to itself or same data type. So here, this next PTR is a pointer to an object of type node. Pointer to an object of type node referred to as a link. So in the linked list terminology, we either say it is a link to the next node, or we say it is a pointer to the next node. Okay. Now let's come to the linked list. Now this linked list is a dynamic memory allocation, right? During the runtime, you can ask, the user can tell you to add a node. So obtain and release memory during execution, right? During the time of execution, you can increase the number of nodes or you can decrease the number of nodes. So to make it happen, there is a very important library function or a built-in function called as malloc. M standing for memory, alloc is a short form allocation. So it allocates the memory of the required size. This malloc built-in function or the library function takes number of bytes to be allocated. Means what? It is going to return the base address of a block of memory. It's going to return the base address of a block of memory. How much size, that how many bytes that you have to specify. So it takes number of bytes to allocate, that is one. This take number of bytes to allocate can happen using a size of, right? Size of is an operator which will allocate the number of bytes which you want it to be allocated. So use size of to determine the size of an object. The malloc function, it returns a void pointer. It returns a void pointer. This is a special quality of malloc. It returns a void pointer. And what is a void pointer? A void pointer is a pointer which can be typecasted to any other type of pointers. That's the beauty of that. A void pointer may be assigned to any other pointer. Means what? The void pointer can be converted into int type of a pointer or float type of a pointer or node type of a pointer. So we are going to utilize this particular feature of this malloc function. The other aspect of this malloc function is that for some reason, if the memory allocation fails, then it is going to return null value. It's going to return null value. Now, when will the memory fail? The memory can fail if your RAM is running out of the memory, or you are asking for such a huge size of memory allocation that the RAM cannot accommodate, right? Now, the beauty of malloc is that it's going to allocate that block which is a contiguous memory and freely available for you to use. So if you ask the malloc function to allocate 1 gigabyte of free memory, probably you are asking too much, right? So in such cases, the memory allocation will fail. But if the memory allocation fails, it is not going to throw you out of the program, but it is going to return a null value. Example. Now, in this example, as you are seeing it, the malloc function, the size of int. Now, if you make an assumption that your compiler is taking 4 bytes for storing a integer value, then the size of int is going to return 4, right? So malloc function is going to look into your RAM and look for a 4 bytes of contiguous memory which is free, right? But this malloc function, as I have told you, is going to return a void pointer, right? So from here to here is going to return a void pointer, and from this particular first half of your statement, that is, you are typecasting this void pointer into an integer type of pointer. Why we are doing it? Because on the left hand side we are declaring int ptr, which is a ptr is a pointer which is capable of storing the base address of another memory location, which can store only integer values, right? Which can store only integer values. Now, the moment the allocation is successful, the base address of that is going to get stored in PTR, and at that memory location, you can store only addresses of addresses uh, which at which there are only integer values, right? So at this address location, you cannot store float values, or at this address location, you cannot store character values. So that is what is the malloc. Now, a pictorial representation, for example, taking an example. Now, size of int. Now, this size of int is going to return 4 bytes, and inside this bracket, you can have an expression like this: 5 into size of int, right? So what we want is that 5 multiplied by 4, that is, we want a block of 20 bytes of memory location. We want a block of 20 bytes of memory location. So it's going to look into your RAM, look for a contiguous 20 bytes of free memory location, pick up the base address, and return a void pointer. Now we are typecasting it. So the base address, assume that the base address is 1000. In PTR, you are going to store 1000. And at this particular location, you can store any integer values. You can store any integer values. So this is what is your malloc which is doing. Similarly, we have a calloc function. The difference between malloc and calloc is that in calloc, the calloc function can take two parameters, unlike your malloc function which takes only one parameter. So the first part is a integer value, and the second parameter is the size of, right? The second parameter is the size of. It does the same job. It does the same job that if integer is going to take 4 bytes of memory, the size of int is going to return 4 bytes, but that will get multiplied to 5, and overall 20 bytes of memory gets allocated. Overall 20 bytes of memory gets allocated. Okay. Are you talking about this, Afra? Are you talking about this, Afra? Okay. Right. So the other advantage is that in other like dev plus, it initializes the location with 0 values, but in other compilers like Turbo C, you may continue to have some garbage values at these memory locations. So calloc function, like in a Turbo C operation, it is going to clear all the memory space with all the previous garbage values and initialize that with 0 if, in case you have int. If you have a pointer of char type here and here, then it will all these values will be null values. Okay, that's another advantage of calloc. So comparison malloc and calloc is that malloc has got only one parameter, whereas calloc will have two parameters, right? malloc uh, in some compilers may return the garbage values, whereas calloc will clear this garbage value and initialize with a default value. The third one which you should remember is reallocation. Reallocation is what now presently I have at this point I wanted a size of 20 bytes, a block of 20 bytes I wanted, so I decided that 5 should be the size. But during the course of my program, suddenly I realized no, it needs to be increased to 10. It needs to be increased to 10. So you can use a realloc function, this pointer. So this particular pointer, this pointer, which initially was modified, gets modified to the base address, which is of 40 real. location. Hello, hello. Oh my God. Hello, hello, hello. What? Hello, 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 hello. What should I do? Hello, 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 hello. One, two, one, two. Hello, 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 hello. Audible now? Not as good? Okay. You always give me shots and you recover me from the shot. It's better now? Hello, hello. Testing one, two, one, two. Is it better now, students? Hello, hello. Testing one, two, one, two. Is the voice breaking? Or are you able to hear me clear? Hello, 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 hello. One, two, one, two. Hello, hello. Clear. Okay. I think there is a huge problem with the internet connection. That's why intermittently it is creating problems. Okay. So your realog realize the usually familiar with free. What does this free function do? Now the malloc and calloc helps in hello again breaking. Oh my God. Hello, hello, breaking. Hello, 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 hello. Now it's fine. Voice is breaking. Wow. Tejaswini says fine, and Teja says it's breaking. Hello, hello, hello. Sandeep again. That was in between students are saying voice is breaking. Now it's no. My internet is quite stable. Sorry. Yeah, yeah. My internet is good. Uh, no, but when the students start saying, most of the students start saying breaking. So if only one or two students are saying that I can. Hmm, I see. Let me check with students. Students, how is the voice quality now? Testing one two one two one two. Hello, hello. Yeah, now they are saying nice and clear. I don't know what can. But you tell Mahesh and Ramon that something can be done. Okay. They have that meter, no, internet speed. So in case such issues come from our side, they should switch on the meter and maybe so that we can optimum beyond this level. Yeah. Okay, students. So now that the voice quality is better, we'll resume. Now let me explain you how we are going to use this linked list. Now this list, a single linked list, is a linear and dynamic data structure. Linear in the sense that one node is connected to other node. So if you want to go to the last node, you have to start from the first node and progressively you have to go to the next and reach the last node. So single linked list is an example of linear type of a data structure, but it is dynamic. Dynamic in the sense that you can increase the node, you can decrease the node. So it comprises of two parts. One, you have to obviously have a structure, and one of the element has to be a pointer. It forms a chain of nodes with the pointer representing the connectivity to the next node in the chain. A linked list can be presented diagrammatically like this. So as you are seeing it on the screen, as you are seeing it on the screen, this is your node. Now this particular node has got two elements as I had shown it in the previous slide. The first is a integer type and the second is the self-referential pointer. Now in the linked list, you must have a special pointer. And what is the job of the special pointer? The job of this special pointer is that it will store the base address of the first node. It should store the base address of the first node, right? So the nodes are arranged in such a manner that the base address of the second node is stored in the pointer in the first node. The base address of the third node is stored in the second node pointer. The base address of the fourth node is stored in the pointer of the third node, right? And if the fourth node happens to be the last node, the point, right? Every time you are traveling, first stores the base address of the first node, right? It means it's not pointing to the linked list, right? So first thing you must check is that whether the first pointer is null or not. If it is not null, then it is pointing to some base address. Now, once you are at the first node, again you should check whether this value is null. If this value is null, it means that the linked list presently is having only one node. If it is not null, then it is having a link of the next node, right? So on and so forth. So when it comes to the last node, if the last node is having a null value in the link, it means that it is the last node in the chain of your linked list. It's the last node, the chain of your linked list. So it's very crucial that you must have a special pointer, what is first pointer, which is always pointing to the first node, and the last node is always pointing, the pointer in the last node is having the null value. The pointer in the last node is having the null value. So this is the assumption which you are going to make. So this linked list has four nodes as I had explained already. So since I explained it completely, so I will go to the next slide. The key part of the linked list. Sure, sure, boss. I'll explain it once again. The the linked list, the linked list can be handled better if you have a special pointer called as first. Name of the pointer is first. So this first pointer is always storing the base address of the first node. Now what is every node? Every node, as described, as shown in this diagram, every node has got two elements. The first element is of integer type. The name of the element is data, and the second element is link. The name of the second element is link, which is of a structured type. Means what? It's a pointer. It's a pointer which stores the address of the next node. And what is every node? Every node is a dynamically memory. The memory is allocated dynamically. Hello, 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 hello. Is it is the audio again disturbed? Hello, 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 hello. Am I audible, students? Hello, hello. Can you hear me? Hello, hello, hello. Somebody saying log audio, sir. Audible, sir. Audio clear, clear, clear. Audible and clear. Okay. So the the link which is a pointer to of struct node type, it is storing the base address of the next node, right? So the last node, the pointer of the last node, if it is storing null value, it means that it is not connected to the next node, not connected to the next node, or this is not or this is the last node in the linked list. So you identify the last node in the linked list. The last node in the linked list has got a null value in the link. Link is a pointer of struct node type. Link is a pointer of struct node type. Okay, so yeah. So now let's how to diagram code. How do we convert this diagram into the C code? A structure each node. Now, as per the diagram, I had shown that the node contains two elements. One was data, and the other was a pointer of struct node type. But that does not mean that a linked list can have only two elements. As we are seeing it in this code, struct node, first element is your char name. It is able to store a string, a char name, up to the size 20. The second element is int age. You can store any integer value. And the third is a node pointer next, right? Is a node pointer next. So it is not necessary that the node will have only two addresses. Node will have only two elements. It depends on your application and your definition. As per your application, you create a structure, and as per that structure, it can store two or more than two elements. So the point to be noted here that one of the elements has to be a pointer of same data type. If I have created a struct node, it has to be a pointer of struct node type. It has to be pointer of struct node. So this first is going to store the base address, So to initialize uh, before you start adding a node, the first is null. The first is null means what? Your linked list does not have any nodes, right? So to initialize, to start the process of initialization, the first pointer, which is of struct node type, is having a null value. If the first is having a null value, means there are no nodes. As you start adding the nodes, the first is going to have the base address of the first node. The first is going to have the base address of the first node, and every node you have a address to the next node except the last one. The last one will have a null value. The last one will have a null value. Now let's start building it step by step. Let's start building it step by step. Now we have a struct node into data and struct node pointer to the next. What does this first indicate? This first indicates that the name of this node is first, right? The name, and that too, it's a pointer. It's a pointer of struct node data type. Means what? It is capable of storing the base address of a node type. It's capable of storing the base address of node type. So in the main, I say int I is equal to 0, first is equal to null. Means what? When the situation is such that we do not have any nodes in our linked list, we initialize this first with null. We initialize first with null. Okay. Since I explained this, I'm going a little faster. I'm skipping this slide. Okay. Now, what we do, we always when we add a node, when we add a node, when we add a node, we store the base address of this node into a temporary pointer. Now, if you look at the code, what do we have in this code? We have a struct node. The name of the node structure is node itself. The first is a string element and the next. The name of the pointer is next. It's a pointer of struct node type. Means it is capable of storing the base address of a user-defined data type, which is struct node type. Right? Now we have declared a pointer called as temp. Now this temp pointer I'm initializing. Struct node malloc size of struct node. Now if you see the code, how much will be the size, assuming that integer takes 4 bytes, assuming that integer takes 4 bytes. So those students who have joined new, please answer. All the students who have already mastered this linked list did not come. Those who, I think IT section had an issue because you could not attend the classes. So anybody from IT, how much will be the size of value, right? Struct node. Assuming that integer takes 4 bytes. Assuming that integer takes 4 bytes. So how much will be the value returned by this struct node, size of struct node? Any one of you? Can anybody visualize how much size of will return? Straight away, 20 bytes for your char. Char takes only 1 byte and integer takes 4 bytes. But you have one more node pointer, Venkat Ganesh. So as Rohit is saying, Rohit is saying, it returns 28. Why 28? Because every pointer occupies the same space as the space required for an integer value. So since this int is requiring 4 bytes, so this pointer also requires 4 bytes. So 4 plus 4, 8, 8 plus 20 is 28. So as Rohan is suggesting, we require 28 bytes. So this size of is going to return, is going to look into the RAM, is going to look into the RAM a memory location which is contiguous and free, which is contiguous and free. And if the allocation is successful, then that those many bytes are allocated, right? Those many bytes are allocated. Now what the second part we are doing, we are typecasting this void pointer to struct node type and then storing temp. So suppose the base address of this is say 1000. So in my temp, now the base address 20,000 will get stored. Base address 1000 will get stored. Now why I'm showing this is because before you start building your linked list, first you have to create an isolated node. Yes. Yes, Nikhil, it is struct node next, not node next. Rightly observed, Nikhil Reddy. It is struct node next. Yes. Nikhil Reddy, it should be struct node next. Unless I type def type if it is type def, then I can say node. But since I have not type def it has to be struct node. Thanks for observation. Struct node, right? Okay. If it is type def, then we can use that name of the type def and use it over there. What is type def? You are asking. Type def, what it does, it helps us. It helps us in naming this memory location. Type def, it helps us in naming this memory. Every time instead of typing struct node next, if initially if I say type def struct node and give this name as node, then I can use this node as that data type. Nikhil Reddy, am I clear or not clear? If I write this statement as struct type def struct node, and here I write it in capital as NODE, then this capital NODE will always refer to struct node type. Will always refer to struct node type. No, type def and struct this type of definition and type def, it is going to allocate same memory. In both the cases, it is going to allocate 28 bytes of memory, right? Only advantage by using type def is that for further statements, I every time need not have to repeat struct node pointer next. I can only say capital NODE pointer next. So you can reduce the code by creating it as a type def. That is the advantage. That is the advantage. Okay. So what we do, what we do before we attach a node, we create an isolated node. Now, if you want to add this particular isolated node, there is no point in keeping an isolated node somewhere in the memory because we are building a linked list. Because we are building a linked list. So what we do is that first we declare the space for the pointer. First we declare the space for the pointer item and assign a temporary pointer to it. This is done using the new statement as follows. For example, I have created a temporary pointer called as cur. This is that cur, this is the first and this is the last. All this cur, first and last are the pointers of struct node type. So cur is capable of storing the base address of a pointer of struct node type. Okay. So what we do, we create a temporary and isolated location, initialize the data value, and presently initialize this particular with null. Initialize this with null. Okay. So adding a node at the end, the simplest way is to add the node at the end. The simplest way is to add the node at the end means what? Previously, we have made an assumption that the last node is identified. The last node is identified by checking whether the next pointer is having a null value, right? So if you want to attach a new node, the base address of this particular node is assigned to the null value. Let me explain this with a diagram. Let me explain with this with a diagram. Yeah, sir, int pointer link or struct node link. It has to be Saurabh, it has to be struct node type, not int. If you have to declare a integer pointer, then you say int. But now we are declaring a struct pointer. Now we are declaring a struct pointer. So it has to be a struct node link. See, Saurabh, it is like this. Now, when you create a structure, it is a self-referential structure as far as linked list is concerned. Why? Because a linked list is a chain of nodes. It is not only one kind of a node, but it is a chain of nodes. If it has to be a chain of node, you have to make a provision to store an integer value, and you also have to make a provision to store the base address of the next node, right? So The next has to be a struct node data type, right? The next has to be a struct node data type. Now, when you want to insert, if you see the code over here, when you want to insert, what we have done, we have written a function. We have written a function called, the name of the function is insert. The name of the function is insert. Now, the first statement is you are prompting to the user. You are prompting to the user, enter the next element, right? Now, using the scanf, you are saying ampersand of cur of pointer data. Now, those students who are listening to this particular lecture for the first time, a word about this arrow operator. Now, arrow operator is the operator which you have to use if cur is a pointer of struct node type, right? If you want to access the element of the structure using a pointer, then you have to use an arrow operator. Once again, when to use an arrow operator? An arrow operator is used to access the element of the structure using a pointer. What is cur? As you are seeing in the second statement, cur is a pointer of struct node data type. Hello, 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 hello. Can you hear me now? Hello, 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 hello. Can you hear me now? Hello, hello. Okay, okay. So let me explain the code. Insert is a function. लावतोय तर कधी येते कधी येत नाही. 5 मिनिटं मला क्लास सांगतोय. Wait for. Okay. So let me explain the insert function. We are declaring a cur, right? The cur is declared somewhere before, as you have seen it in the previous slide. I have created the cur pointer as shown in the previous slide. Let me take you to the previous slide. See here, struct node pointer cur, right? So Globally, I have already declared the struct pointer. I'm Venkat Karthik, I'm coming to it. Please hold. I'm coming to it. Please hold. So, uh, this curve is already globally declared, and we are storing the base address of a block of 28 bytes, right? Then, through the user, we are asking the user to enter the data. That entered data is stored at this particular data location, right? Now, make an assumption as I'm showing it graphically. As I'm showing it graphically, previously you have some linked list. Previously you have some linked list. The last node in the linked list is null, right? Previously you are having some linked list and the last node is null, right? Now at this particular statement, what we have done, we have created a block of 28 bytes and the base address of this is stored in cur. Then what we have done at this particular step, we said cur of data and the user assume that the user has entered 10. So 10 gets stored over here. Then what we have done, cur of link is equal to null. So this particular link is initialized to null. Now what we are doing, last of link. What is last? Last is a pointer which is storing the base address of this particular last node, right? So the last of node which previously was null, I am replacing it with cur, right? So previously it was null over here, and make an assumption that the base address of this is 1000. So 1000 is stored in cur. 1000 is stored in cur. So when I execute this statement, the last of link is equal to cur. So this null value is going to get replaced with the base address of this cur, and last is equal to cur. Now what we should do, that is how we have attached the previously existing linked list with one more node called as the last node. Now presently the last is standing here, which we have to advance it over here. So the last statement which you are seeing on the screen, that is last is equal to cur, when you execute this, the last goes from here and last comes at the last point. That is how we attach the last node in the linked list, the newly created node in the linked list. K. Naga Venkat Karthik. Have you understood this? Can you repeat the last step? Okay. Sheikh Obed, it is like this. Presently, you have a linked list. You have a linked list in which the last node is having null value, right? The link in the last node is having null value, right? As I told you earlier also, that how do you identify the last node? We identify the last node when the address in the link is null, right? So some nodes are there and the last node, the link is having null value. So before that, from this step to this step, we have created an isolated node. That isolated node, the base address is stored in cur, right? Now, if I want to attach this isolated node to the existing linked list, so I have advanced the last, made it stand to the last, and at this particular step, what am I doing? Last of link, that is last of link is equal to cur. So instead of null, this cur value, which we are making an assumption that it is 1000, so this null gets replaced with 1000. If it gets replaced with 1000, this particular link is connected to an isolated node like this, right? So last of link becomes cur. Now, after attaching the isolated node, this is no more the last node. This is last but one node. So what we need to do, we have to advance this pointer over here. How do I advance this pointer over here? I simply say last is equal to curr. Make an assumption that previously last was storing this base address, say 500. The base address 500 was stored in last. But now, because I have added a new node, the last should come over here. So last is equal to curr. What assumption we have made? The base address is 1000. So last is equal to curr means last becomes 1000. So last and comes and stops at the last node, right? So this is how we attach an isolated node into the linked list. Clear? Right. So students, we are stopping the class now, and in the next class I will show you the complete code of how to build the linked list, right, which comprises of insertion at the beginning and displaying the number of nodes in the linked list. So for today we are stopping. And since a lot of requests have come from students to enable the videos, so maybe by maximum tomorrow we are going to upload all my videos on the Delhi University, right? So you will be able to refer, go through my previous videos and try to understand wherever you have any doubts. Still, if the doubt persists, in spite of seeing the videos, in the current class, you can always have the clarification.